Holding Global Insulator Group cares about reliability of the products it supplies. The Technical Consulting Department, GIG Operations Service, whose aim is to study the insulator's quality in order to keep its operating characteristics. Insulators of type PS12A and PS70E, both of 1973 and 1996 respectively, produced by Elektroset Izolacja in the USSR, were dismounted in 2014 from the high-voltage line 500 kV Iraklinskaya Hydroelectric Power Station, Magnitogorsk Substation, and the high-voltage line 500 kV Yuzhno-Uralskaya Hydroelectric Power Station, Troitsk Substation of the Yuzhno-Uralsk Enterprise Main Power Network's energy grid operator Roseti, because of frequent shutdowns. On order by the GIG Operations Service, insulators which had been dismounted were tested in the accredited test laboratory UIEs against the IEC standard 6490, capable of natural pollution without any cleaning. The first stage of substation 500 kV Magnitogorskaya with the feed line 500 kV Iraklinskaya Magnitogorsk was constructed and put into operation in 1976. This provided the electricity supply for the industrial district of Magnitogorsk, including the hugest consumer, Magnitogorsk Iron and Steel Company, MMK, and the south of Chelyabinsk region. In 1978, the second stage of substation 500 kV Magnitogorskaya was put into operation with 500 kV high-voltage line Troitskaya Hydroelectric Power Station, Magnitogorsk, with the capacity of 1,362 MVA on station. In 1976, despite the conditions of the industrial pollution on 500 kV high-voltage line Iraklinskaya Hydroelectric Power Station, Magnitogorsk, the insulator of type PS12A with the standard profile was used. As a result of visual inspection, we may see that the forms of pollution include dust and dead spots. This is a mixed type of pollution. The research of electrically conductive deposits, equivalent salt deposit density, ESDD, and non-soluble salt deposits density, NSDD, is the key point of these studies and selection of the insulation. Sometimes non-soluble deposits greatly outweigh the salt deposit levels that accumulate on the exposed insulator and metal surfaces. Under human conditions and when in contact with metal, this non-soluble dust can lead to accelerating metal corrosion. Usually dry insulators don't flash over, even if they are highly polluted. However, affected by the rain or condensation on the polluted surface, a partial discharge may occur. The degree of discharge activity depends on the type of the surface, whether it is wet and forms the continuous water layer, or it is waterproof due to its qualities. 25 insulators were chosen for tests. 12 different tests were performed for each type of insulator. Verification of the dimensions and weight of insulator type PS12A. The creeping distance range is within 317 to 322 millimeters. Verification of the dimensions and weight of insulator type of PS70E. Creepage distance is 315 millimeters, which is within acceptable standards. Insulators meet the IEC requirements. Verification of thickness and quality of coupling of the zinc coating of the PS12A insulator. Thickness of the zinc coating of the pin, 101 to 110 microns cap, 127 to 182 microns. Verification of the quality of zinc coating of the insulator of PS70E, the pin, 108 microns, the cap, 165 microns. Insulators meet the IEC requirements. The The radio frequency interference limits test of PS12A and PS70E types of insulator. The interference level did not exceed the accepted level under the limit test voltage. The step-like rise of the interference level under voltage increased up to 110% of the standard test voltage is absent. Insulators meet the IEC requirements. Lightning impulse withstands the voltage test with waveform 1.2 per 50 milliseconds. Dry insulators should withstand standard lightning impulse voltage of both polarities. The value of the test voltage for the insulator type PS12A is 118.3 kilovolts, and for the insulator of type PS70E is 103 kilovolts. Standard withstanding voltage for the insulator of PS70E is 100 kilovolts. 15 impulses were applied. Testing voltage is 103 kilovolts. The insulator passed the test. The insulator of type PS70E meets the IEC requirements. Insulators passed the tests. No flashover and puncture have occurred. Power frequency withstand voltage test, wet. The test was administered by application of standard voltage to the insulators. Test voltage for the insulator of PS12A was 45 kilovolts. Application of voltage continued for 1 minute. The insulator didn't pass the test. The puncture occurred at the level of 40.1 kilovolts voltage. Insulators of type PS12A do not meet the IEC requirements. An insulator of type PS70E was tested by application of standard voltage. The test voltage was 40 kilovolts. The application of voltage continued for 1 minute. The insulator of type PS70E passed the test. It complies with the IEC standard. Mechanical failing load test of the insulators of type PS12A and PS70E. The insulators passed the test because the mechanical failing load was higher than the standard voltage and no puncture occurred. Temperature cycle test. Insulators of type PS12A and PS70E have been subjected to the 3-stage heating and cooling cycles with a temperature drop to 70 degrees Celsius. The insulators had been submerged in cold water and hot water bath for 15 minutes. As a result, during the visual inspection, no cracks or fractures in the cement joint of the insulators were revealed. The insulators meet the IEC requirements. Thermal shock test of the insulators of type PS12A and PS70E. During the test, insulators were placed in a heating oven to 130 degrees Celsius above zero. The insulators remained at this temperature for the next 3 hours. After that, the insulators were completely submerged into a bath of water, which is 24 degrees above zero, and remained submerged no less than 2 minutes. As a result of the test, during the visual inspection, no cracks or fractures in the cement joint of the insulators were revealed. Power frequency puncture voltage test of insulators PS70E type. The tested insulator passed the test because the puncture had occurred at a higher voltage than the standard voltage. The insulator of type PS70E meets the IEC requirements. Power frequency puncture voltage test of the insulators of type PS12A. The insulator did not pass the test because the puncture had occurred at a lower voltage than the standard voltage. Insulator of type PS12A does not meet the IEC requirements. Mechanical failing load test of the glass insulator residues of type PS12A and PS70E. Achieving tension loads of 24 kilonewtons and 14 kilonewtons respectively, the glass insulating part was shattered by the mechanical shock in the test machine. The remaining part is the residue. Then the load was increased until the residue was crushed. Insulators passed the test because the residue was crushed at a load higher than the standard. Insulators meet the IEC requirements. Proof impulse voltage steep front test. Verification of proof of insulators of type PS12A and PS70E under the impulse voltage steep front. Wave steepment is greater than or equal to 2000 kilovolts per microsecond. 10 impulses of positive and negative polarity. Insulators meet the IEC requirements. Thermal mechanical performance test of insulator type PS12A. Glass suspension insulators of type PS12A are in accordance with the IEC standard. The measured value of the failing load occurred between 156 and 183 kilonewtons, while the standard measure is 120 kilonewtons. The insulator of type PS12A meets the IEC requirements. One type of the contamination of insulators in atmosphere is emissions from industrial enterprises, which produce acrid reaction on the alkali glass surface, on which the glass is exposed to erosion. As time passed, the following processes occurred. NSDD and ESDD deposits lie over it and accumulate. Some of them are cleaned by rain and wind, whereas others aren't. To protect from deposits and to improve the quality, it is needed to select the design of the glass part and material of an insulator before its installation. It is impossible to influence such ability of the glass part as self-cleaning, because it depends on natural factors, wind, rain, etc. We may influence the waterproof quality of insulation, the design characteristics of a string, and design of a glass part. Number 1. Aerodynamic profile is designed for easy air blow-off, which contains dust, to prevent from dust fall, and also it is easily self-cleaned by wind and rain. It is good for dry dust deposits. It has a huge creepage distance. Number 2. The insulators of fog type with extended ribs also have huge creepage distance and are designed to prevent moist liquid contaminations. Number 3. To achieve the high discharge characteristics of a string, Global Insulator Group offers the use of mixed type strings combining aerodynamic and fog profile qualities. Mixing insulators of different profiles allows increasing the ability to withstand composite pollutions and discharge characteristics by means of interchange of insulators profile, horizontal and vertical ribs. For variation of aerodynamic and fog characteristics, the interchange of insulators of aerodynamic profile and insulators with such characteristics as extreme ribs, insulator with the extended ribs, fog type are used. Number 4. Salt spray, fat deposits, emissions from industrial enterprises with acid reaction, white frost and icing. In such cases, the presence of ribs in the glass part is not enough. In this case, it is better to use waterproof mixed string. Quality of perfection, perfection of quality.